Ethanol is an alcohol fuel produced by fermentation of sugar found in sugarcane, rice, potato skins and is commonly made from wheat, corn and sorghum. The biofuels can be produced in a number of ways. For instance, ethanol is produced using a process similar to brewing beer, where starch crops are converted into sugars. The sugars are fermented into ethanol, and the ethanol is then distilled into its final form, which can be used as a fuel. Apart from fermentation, ethanol is also produced by the process called hydrolysis, where materials that have lignocelluloses found in the tissues of plants and other organic materials are used. Biomass can also be gasified to produce biogas. Hydrogen is recovered from it and catalytically converted to methanol or ethanol. The gas can also be run through a biological reactor to produce ethanol. Biofuels have been around as long as cars have. At the start of the 20th century, Henry Ford planned to fuel his Model Ts with ethanol, and early diesel engines were shown to run on peanut oil. It is generally seen that ethanol-only engines are tuned to give biofuel could provide significant environmental benefits by decreasing the greenhouse gas emissions because of the fact that these biofuels are primarily derived from crops which absorb carbon dioxide. Thus, the balance of carbon dioxide is sustained and maintained in the atmosphere. It is safe, non-toxic and not detrimental if accidentally spilled because it breaks down very quickly.
What happens in the fields during planting, fertilizing, and harvesting is just as critical as converting corn into ethanol. But for our discussion, we will only consider what happens once the corn arrives at the plant. Upon arrival at the plant, the corn moisture level is tested, and then the corn with the desired moisture level is dropped into a conveying system, which then delivers it to the hammer mill. The corn passes through a hammer mill, which grinds it into a fine powder called meal. This increases the surface area to volume ratio and thereby allows efficient release of starch from the corn. Shortly after grinding, the first enzymes are added to start the breakdown of the starch to sugar. The meal is mixed with water and alpha amylase, and then passed through the jet cooker where the starch is liquefied. Heat is applied to enhance liquefaction. Jet cooking with a high temperature stage is used, where the temperature is typically between 120 and 150 degrees Celsius. High temperature also eliminates bacterial contamination in down processing. Yeast is added to the saccharified mash to ferment the glucose to ethanol and carbon dioxide. Fermentation is usually operated in a batch mode. The mash stays in the fermenter for about 48 hours for completion of fermentation. The mash exiting from the cookers is cooled down, and the enzyme glucoamylase is added to convert the liquefied starch into glucose or dextrose. For illustration reasons, the animation shown here is for a laboratory-scale distillation process. However, the full-sized process is similar. In general, the fermented mash, known as beer, contains about 15% ethanol and non-fermentable residues and yeast cells. The mash is then passed through a distillation column, where the ethanol is separated from the solid residues and the water. The ethanol comes out from the top at about 190 proof, and the unfermented residues, called stillage, are collected from the bottom of the column. The whole stillage is passed through a high-speed centrifuge, where the solids and liquids are separated. The solids, known as wet grains, are further dried, mixed with solubles known as distillers' dry grains with solubles, or DDGs, and sold as animal feed. Part of the centrate, known as thin stillage, is directly used in upstream processing. The ethanol obtained following distillation is passed through a molecular sieve where the remaining water is removed. The ethanol at this stage is called anhydrous ethanol and is about 200 proof. The pure ethanol is denatured with a small amount of gasoline, 5%. This is done at the ethanol plant. The ethanol is then shipped to various gas stations around the country to blend with gasoline to produce E10 or E15.